Kia ora Year 12. I've just picked out a few questions from exercise 9b to look at separating the variables for differential equations. Now I'm doing these because I think we've gone a little bit too fast for some of you in class when we're working with the constant of integration, and so I've just pulled these four out to go over. So here they are. Have a go at them first, pause the video and see how far you get. Okay, so the first question is this. We've got dy by dx is xy squared, and we're going to start by separating the variables. So we get 1 over y squared dy is equal to x dx. And now we're going to integrate both sides with respect to the relevant variable. So on the left hand side, I've got the integral of y to the negative 2, and on the right hand side we integrate x and get half x squared plus c. Right, now we've talked quite a lot about how we're just going to have a plus c here and not on both sides. I'm not going to go on about that anymore. Remember, you've got the page of delta to read if you're stuck on that bit. Integrating the left hand side now, I get negative 1 over y equals a half x squared plus c. Right, now the next thing I'm going to do here is I'm going to get a common denominator for the right hand side. So we're going to make this over 2. This is where the funky thing happens. Usually when I multiply c by 2, I end up with 2c. But because that's just an arbitrary constant, we're just going to leave it as plus c. Now that will feel strange. If we want to be really uptight, we could do this. We could let c dash equals 2c, and we could have the right hand side be this, x squared plus c dash on 2. But we generally don't bother with that because usually we're using a general solution to solve a problem. Okay, so we could do that, but we're not going to bother. So where does that leave us? Well, we've still got our negative 1 over y. So from here we get y is equal to negative 2 over x squared plus c. And if Ryan is watching, Ryan, this is the one that I butchered in class with you the other day, so hopefully that makes much more sense now. Okay, on to question 3. Okay, 3 goes like this. Dy by dx is equal to y. Separate the variables. 1 over y dy is equal to dx. Put back in the invisible 1 and integrate both sides. That leaves me with the natural log of y is equal to x plus c. Doing e to the power of both sides, we get y is equal to e to the power of x plus c. There's a couple of little things to notice here. The first is that I've mysteriously dropped the absolute value signs. I can do that because e to the power of anything will be positive, so I know that I don't need my absolute value signs because y is always going to be positive. The second thing to note is that I can split this up as follows. So I get y is equal to e to the power of x times e to the power of c. This is an arbitrary constant, so our final solution for this one is simply y is equal to a e to the power of x. There are quite a few common constants of integration that we use. A is a really common one. The other thing you might see for that is k e to the power of x. Okay, 2 more to do. The next one is number 5. So dy by dx is equal to y over x. I've picked this one because the pattern with the constant is a bit different again. We have 1 over y dy is equal to 1 over x dx, and we integrate both sides, giving me this. The natural log of the absolute value of y is equal to the natural log of x plus c. So that's how we do it if we were just starting out. But I want you to notice here something else I can do with this. It's going to make it a bit easier. C is an arbitrary constant, so I can transform this into the natural log of x plus the natural log of c. Now I can apply my log rules from year 11 and put these two together, and it's going to get much nicer. So on this side I'm now going to have the natural log of cx, and on the left hand side I've still got the natural log of y. So to undo a natural log, we go e to the power of. Doing that on both sides, we're left with y is equal to cx. Okay, I think out of the first few in this exercise, that's probably the one you're going to find the weirdest. But I wanted to put one of the slightly harder ones in as well, so now we're going to do question 8. Okay, so 8 goes like this. Dy by dx is x blah blah blah. I'll stop talking. There we go. Right, so separate your variables, all of the y's over to here. We get y on y squared plus 1 dy equals x on x squared plus 1 dx. And integrating, I stop and I take a little look. Now we'll notice our common pattern, that I've got a denominator here and the derivative of the denominator is 2y. Up here I've got y. So I'm happy with that. It means it's coming out of a natural log function. Remember, the general rule is this: if I've got f dash of x over f of x, then that's come from the natural log of f of x plus c. Okay, so what do we get here? Well, on the left hand side, when we integrate, we get 1/2 times the natural log of y squared plus 1 is equal to 1/2 times the natural log of x squared plus 1 plus c. Right, two things to have a look at here. The first is the half everywhere, and the second thing is that I don't need my absolute value signs here either, because y squared plus 1 is always positive. So I'm going to do two things on the next slide. You'll see when you turn the page. Right, so just getting rid of the absolute value signs first. We have this. Now I'm going to multiply both sides through by 2 to give me this. But when I multiply c by 2, I just get c, not 2c. Right, so 2c is just becoming c. Okay, now I'm going to then say, oh, well, that plus c might as well be a natural log of c. Okay, so what I want you to get really comfortable with is all of these weird things we're doing with the plus c. If you've still got questions, send me an email, or we can talk about it more in class. Putting those together, I get the natural log of c times x squared plus 1. Right, using my log rules, which gives me y squared plus 1 is equal to c times x squared plus 1. So my general solution here is y squared is equal to c times x squared plus 1, take away 1. And it's okay to stop there, or you could do this. Y is equal to plus or minus this. The reason it's fine to stop here is that I've separated the y's and the x's. So if you tell me an x value, I can get you a y value. And usually when we're using DEs, we will want to go on and find a particular solution, usually for a particular fact situation. All right, thanks for watching. I've done full worked examples to 9B and I'm nearly finished 9C, so they'll go up, but not until I'm back at school on Monday. Thanks for watching. Stay warm, it's really cold.